Hi everyone, good evening. Welcome back to the session. I hope I'm clearly audible to all of you. Perfect. So let's get started. In the session yesterday, we spoke about spanning tree protocol and looked into rapid spanning tree uh, protocol details, as well as we discussed about some really interesting topics like ether channel configurations, right? The very first thing that we are going to look at today is port fasting, which we missed on discussing in the session yesterday. A very small topic and configuration, but a great feature to avoid unnecessary spanning tree elections. I'll share my screen and it should be visible now. So basically, the port fasting is used for skipping the spanning tree elections on certain interfaces. For example, if I take one switch and I connect a PC with it, simply like this. So we can see there is so much of time this FA0/1 takes to bring up that particular interface, right? Why does this happens? This happens because my interface moves through different port states. It gets into the listening state, then it gets into the learning state, then finally it gets into the forwarding state. But do we actually need the spanning tree elections to take place here on the interface FA0/1? What do you think? Do we need those elections? No, we don't need that, right? Simply because spanning tree is used for avoiding layer 2 loops. And these loops can happen between switches, also in a redundant topology. Now this is a PC. This PC will not be sending me any sort of BPDU messages, right? So I don't need spanning tree to take elections or take place on FA0/1. So the interfaces where I don't want spanning tree elections to take place, I can enable something called as port fast. Okay. How this works, I will go to my switch and let's say I will be configuring or connecting FA02, FA03, FA04, these three interfaces with end devices. Okay. So what I can do is I can enable port fasting on them. Interface range FA0/2 to 5. I'll select those interfaces first. Then I'll say spanning tree port fast. Simple. This particular command enables the port fast on these interfaces and also generates a warning that it is configured but will only have effect when the interface is in non-trunking mode. Also, it gives you a warning that use it only on interfaces which are connected to single host. Okay, connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause bridging loops. So we should be very cautious that we enable port fasting only on those interfaces which are connected to end devices like PC, like switch, not switch, sorry, PC or a server or a laptop or maybe IP phone. So such devices where we connect, we can enable the port fasting on those interfaces only. Right now, I have enabled it on FA0/2, FA0/3, FA0/4, and FA0/5. So now, if I connect any device with FA02, FA03, 4, 5, they'll not take a lot of time because STP elections will not take place there. So I'll put my cable on PC. Then on switch, I will connect it to FA02. Do you see that? It immediately got into the forwarding state. Similarly, if I connect my cable, there you go. Very immediately it gets into the forwarding state. Why? Because there is no spanning tree elections happening on these interfaces. So whenever I'll connect some device on FA0, 2, 3, 4, or 5, they'll immediately get into the forwarding state. But when I'll connect some device on an interface which is not enabled with port fasting, it will take its enough time to move from listening to forwarding state. First, it will take 15 seconds to get from listening to learning. Then again, from learning to forwarding, it's going to take another 15 seconds. So those timers or those delays can be avoided by enabling port fasting. Any questions or doubts in this? Command is very simple. First, you will get into the interface configuration mode, and then you have to type spanning tree port fast. Yes, it is used to avoid the wait time and put the interface directly into the forwarding state. Ravi, if you will stop spamming this, then only I'll be able to explain, right? We are looking at port fasting. Let me take my time to explain the topic. I'll get there. Don't worry. Yeah. Right now, the question is that is there any doubts in understanding port fasting? Yep, sure. Port fasting is used on interfaces where we want to skip spanning tree elections. Okay. Understand this that we don't want port fast to operate on trunk ports because trunk ports are connected to switches. Do you agree? And if I connect a switch, let's say on a port fast enabled interface, spanning tree elections will not happen there and this can lead to loops, correct? So we only enable it on interfaces which will be connected to end devices like PC, laptop, server. Okay. So we enable it simply to avoid the spanning tree elections and so that we don't have to wait for a delay and we can directly bring the interface in the forwarding state. Okay, we have a question. What is spanning tree? Prabhat, we discussed about that in the session yesterday. So spanning tree is used for avoiding the loops in a redundant topology. On Nexus switches, there is an option of port type as network or normal. Right. There are two types of ports. The normal is the default mode for the Nexus devices, which participates in spanning tree, CDP, LLDP, all these things that we discussed, the layer 2 operations. Whereas when we speak about network port, they are used for establishing your tunnels, the fabric connectivity. So there we do not use layer 2 mechanisms as they are used for special purposes. I'll increase my font size 1 second, although I think it's large enough, but better now. Okay. Now, just like port fasting, there are some more additional security mechanisms that can be used for implementing a better spanning tree topology. The very first out of that is root guard. Root guard is used to protect the root bridge of the topology. Okay. So I will just delete these end devices. Let me just completely delete the setup and add a new set of devices. I'll take 3 switches, switch 1, switch 2, switch 3, and I will connect all of them like this. Okay, my spanning tree topology is up. The interfaces are in the forwarding state. FA0/1 of my switch 2 is considered as blocked port, right? So this interface is blocked here, rest everything is up. And if I check the details, so if I go and check my switch 3, let's say, enable show spanning tree, I can see this is the root bridge, right? So what I will do is now let's say this is my corporate network. I did a lot of planning plotting and I decided that according to my planning, switch 1 should be my root bridge. So I went on to switch 1 CLI and I said that I want the spanning tree VLAN 1 priority for this switch as 8192. Now, when I say that I want the priority to be 8192, after that, I can say my switch 1 will become the root bridge. As we can see, this bridge is the root. So it became the root bridge now, right? Now, I want to make sure that under no circumstances, any other switch should become the root bridge of the topology. Okay. So it will always be my switch number 1, who should be the root bridge of my topology. So that is where root guard gets into picture. Root guard makes sure that no one else can become spanning tree root bridge. Okay. So you can enable it on the ports where your other devices are connected. Like right now, root bridge is switch 1. So I can enable root guard on FA01 and FA02. What it will do, when it will receive a BPDU message, which is superior, basically a BPDU message having a lower bridge ID or maybe a smaller priority from any of the switch, be it switch number 2 or switch number 3, it will put my interfaces into root inconsistent mode, okay, which is kind of blocked mode. So basically, if someone else from my topology will try to become the root bridge, I will shut down these interfaces. I will put them in a blocked mode where they'll stop operating, because I have personally decided that it should be switch one always who should become root bridge. Okay. So if someone else is sending a superior BPDU message or is trying to become a root bridge of the topology, then there is a possibility that there is someone who is trying to attack my topology. Okay. So this is only enabled under situations where you are quite sure that it should always be a particular device who should be the root bridge of the topology. Like in my case, I'm sure I want switch one always to be the root bridge. So I'll go to my switch one. I'll select the interfaces which are connected to the downstream devices. So FA01, FA02. And here I will enable root guard by saying spanning tree guard root exit. Once I do so, if these devices will ever try to become a root bridge, my switch will put these interfaces into block mode. Let's try to verify that. I will go and I'll put a priority of, let's say, 4096 on my switch 2. If I set the priority as 4096, can I say that switch 2 will try to become the root port? Yeah. If I hit the enter button, do you see? The moment I hit the enter button, FA01, FA02 both became root inconsistent. They will try to protect themselves as the root bridge of the topology and will not come up until and unless I fix this configuration here. So that's again a mechanism where you can avoid attacks where possibly someone can try to become your root bridge of the topology. Okay. So I'll fix this situation again by setting a priority back to the default value 32768. Once I do so, my switch will stop receiving the superior BPDU messages from switch 2 and eventually my interfaces will come up. If I skip the time, we can see the interfaces are up again and switch 1 stays the root bridge of my topology. That's how the root guard works. Any questions or doubts in this? Ravi, my friend, please let me just continue with the topics. Don't worry, I will address the BPDU guard questions also. Just give me a minute more. I want to know if everyone is clear with the root guard or not. What is a superior BPDU? A BPDU message having a lower bridge ID will be a superior BPDU. So if someone is better than me, that means they have a smaller priority than me. So I will consider them as superior from me and they'll be sending me superior BPDU messages. Yes, Sayyad. Definitely, this is used only in those situations where you are sure that you will never change the root bridge of your topology and you put it just to make sure that no attacker can manipulate the STP decisions by sending superior BPDUs. Michael, the interfaces on which you have enabled root guard, which is basically FA01 and FA02, they will go into root inconsistent state. And this is the command, simple command to enable root guard. Deepti, the relevant questions will always help you in understanding concepts better. Don't worry. We'll continue with the topic, but we need to make sure that everyone is on the same page, right? All right. The next feature now is BPDU guard. Now you see, I said that port fast is something which we enable on the devices which are connected to end devices, right? If I go to my switch and I enable port fast on FA03, spanning tree, port fast, very immediately it turns into the forwarding state. But there is still a possibility that PC6 might send me a BPDU message. Do they generally send BPDU messages? No. Then in which situation a BPDU message might be generated by PC6? Only when PC6 is being used by an attacker. So sometimes attacker might send BPDU messages towards your switch to manipulate the spanning tree calculations. Okay. But we are sure that PC6 should never send BPDU message. So on such a connections or such a interfaces, we can enable BPDU guard. What will basically BPDU guard do? Anytime if my interface FA03 receives a BPDU message, it will understand that PC is trying to inject something malicious or is trying to implement an attack. So I will put the interface immediately into error disabled mode. Okay. How does this get configured? Let's see. FA03 is already enabled with port fast. And then I'll say spanning tree BPDU guard enable. This also enables the BPDU guard on the interface. Now, if in any situation FA03 receives a BPDU message, it will put the interface in the shutdown state or the error disabled state. So what we'll do to verify is we'll disconnect PC6 and instead of that, I'll put a switch. You see that? It never came up. And FA03, if you see, changed state to down and BPDU guard was detected basically, and it put the interface FA03 in error disabled state. So it's a protection that we implement with the devices or the interfaces where we will never expect a BPDU message. Questions or doubts in this? Ravi, is it clear to you now? Now the question is, yes, the port fast needs to be enabled. Spanning tree BPDU guard enable. This is the command to enable BPDU guard. Very good question, Nicholas. The question now arises that what if I'm not receiving a BPDU message anymore? So I'll delete my switch again and I'll connect a PC again. Now this PC will not be sending a BPDU message by default, right? But still my FA03 stays in error disabled mode. So how do I recover it? To recover an error disabled interface, what you have to do is you have to first of all get into the interface configuration mode. Then you have to type down shutdown, and then you have to say no shutdown. So first you have to say shutdown, then you have to say no shutdown to recover the interface from error disabled mode. Exactly. You will have to reset the interface by shutting it down and then bringing it up again. That's how the spanning tree security mechanisms work. I hope this made sense to all of us. Now, the next topic that we are going to look at is port security. Again, something really interesting, which learns the MAC addresses of interfaces to make sure that only authorized users are connecting to the device. Okay, so let's see how that goes. I'll take a simple topology. I'll create a new topology here, one switch, and let's say 4 end devices. We know that every PC will have a MAC address, correct? What I will do using port security is I will tell my switch number 5 to learn the MAC address of all these PCs permanently. For example, in this case, let's assume that the MAC address of PC8 is AA. So I will ask my switch number 5 to remember that on FA01, there is a PC which connects with the MAC address of AA. Okay. But if in future some attacker gets into the picture and tries to connect on FA01 with my switch number 5, so I want my switch to shut down the interface because this is not the device having the MAC address AA. If the device is not having the MAC address, which I have learned earlier, I will shut down that interface. And this implementation can be done using port security. So let's see how port security can be configured on the switch. What I will do is I will delete this connection and I'll make it back to the default state like this. And we will configure all the devices under 192.168 1.0 subnet. This will have 1.1, 1.2, 1.3, and 1.4. This is we are considering as attacker. So yeah, this will be my attacker. And if this attacker connects on any of these interface, FA01, 2, 3, 4, my switch should shut down that interface immediately. So let's see how port security can be configured. I'll go to my switch. I'll go to the CLI and I will first of all select the interfaces on which I want to enable port security. Enable, configure terminal, select the range of the interface range FA0/124. Here I want to enable switch port security, right? So first of all, I need to make sure that these ports are access ports, for which I'll type down the command switch port mode access. Then I'll say switch port security. This command is used to enable port security. Then there are a few more things that we can configure related to port security. So switch port security, if I hit a question mark, these are the four things that I can mention. First, I will specify what number of maximum addresses my interface should be learning. Like it should learn just one MAC address, or do you want more MAC addresses? You can specify that using the maximum keyword. So if I say switch port security and hit a question mark, I can specify how many MAC addresses my interface should be able to memorize. Okay. By default, this number is going to be set as 1 only. So we will keep it to the default value, which is 1. Then the next thing is I need to specify how the MAC addresses should be learned on these interfaces. If I hit a question mark there, I have two options. Either I can add the MAC addresses statically, or you can say manually by typing down the MAC address one by one. Or otherwise, I can use the sticky method. What is sticky method going to do? Sticky method will learn the MAC addresses of connected devices dynamically from the messages or the packets they exchange. Okay, so that's your dynamic method. Or otherwise, you can go for the manual method where you have to type down the MAC address manually. So I'll go for sticky, enter. Okay, exit. Or rather than that, let me also show you about violation. Switch port security violation, and there are three modes. So what to do basically in the case where port security is violated? Okay, the very first mode is protect. Protect mode will simply drop the packet from the attacker and will not do anything else. Simply going to drop the packet, it will not accept the packet that my attacker is sending. Next mode is restrict. Restrict mode will drop the packet as well as will notify by creating a log message that someone is trying to access your network. Okay. Or someone is trying to violate the port security. That's your restrict mode. Shutdown mode is simply it is going to put the interface in the shutdown mode. So the most secure mode of spanning tree violation is shutdown mode, where it simply shuts down the interface so that no packets can be accepted or no further attacks can be implemented. So I will set the mode as shutdown. Also, this is the default violation mode, which is used by which is used by port security. So if you don't enter this command also, by default, it will work in the shutdown mode. Then I can take the exit and I can check the details by saying show spanning tree, show port security. And I can see it is enabled on FA0, 1, 2, 3, and 4. The maximum addresses that we can learn on these interfaces are 111. Currently, how many addresses are learned? 0. Why? Because obviously we haven't given any IP or haven't exchanged any packets, right? So that's why it's all 0. How many times the security was violated? 0 times. No worries. We will set the IP and we will make the switch learn about the connected MAC addresses. So 1.1, let's say. Then PC9, desktop IP 1.2, 1.3, 1.4. After that, I will make them all communicate with each other so that my switch can learn about the connected MAC addresses. So some exchange of messages will let my switch learn about the MAC addresses. Now I will check the details again, show port security, and now I can see current number of addresses which are learned are 1111. On all the interfaces, we have learned one MAC address. So everything is now ready to be used. My switch is ready. My switch has learned the MAC addresses. And now if on any of these four interfaces, someone else tries to connect, then I will put that interface in error disabled state. Okay, let's see. I'll go to PC12. I'll set the IP as 1.100, let's say. And then I will disconnect my cable from PC8 and I will connect it to this attacker PC12. Let's see what happens with FA01. FA01 became up. It came in the forwarding mode. Does that mean port security is not working? No, it is working. The thing is that so far PC12 has not generated any packet which would contain a different MAC address. We have just connected the cable, right? If I initiate a communication between PC12 and let's say PC9, you can see FA01 turns in the error disabled state. And we can see that here in the logs also. FA01 changed state to down and administratively down. Yeah. So basically the port security got violated. If I check the details on FA01, the violation counter got increased from 0 to 1. As a result, my interface turned down. Now, how do we fix it? If we connect it back to, let's say, PC8, still the interface will remain down. How do we fix it, guys? Let me know in the chat. What command should I type on FA01 to bring it up again? Perfect. Shut, then no shut. And then I can see my FA01 is coming up again, and it's now back in the forwarding state. That's how the port security works. I hope that's clear to all of us. If there is a question or doubt in this, then let me know. I've pasted the lab guide for both of the things that we discussed. Now you can take your time to test out these features, and then we will move to the next topic. You can use ping, Sayed. Ping can be used to send some packets from PC12 to any other PC. Then also, Sham, this will shut down the interface because on PC1's port or FA01, I was supposed to just connect with PC8. But we can still fix this problem. I mean, if you want, let's say these four devices to connect on whatsoever interface they like, then in that case, you can increase the maximum learning addresses from 1 to 4. Okay. So if you will make them learn about all the four addresses on all the four interfaces, my switch will not shut down any interface if any of these devices connect to any of the port between FA01 to FA04. So you can increase the maximum MAC addresses, correct, to 4 so that these devices can one by one can learn about all the four PCs which are authorized to access my network. Ankush, for wireless connectivity, there are other security mechanisms. Wireless devices do not connect on interfaces, right? They connect using radio frequencies. So port security will not work for that. So here, if you are not getting any output using show port security, that means you missed on enabling port security correctly. And you need to type down the command switch port security. I'm I'm guessing that you might have missed writing this command. So this is the command which enables port security. So make sure you have enabled it. All right, I hope everyone must have completed this by now. We'll move on to the next discussion now, which is about understanding another security concept today. So, before we jump on to the next one, is there anyone still working on this or have any questions regarding what we have covered so far? Awesome, great then. We'll move on to the next concept, which is about understanding DHCP snooping. Now, DHCP snooping is a method where we protect our legitimate DHCP server from the rogue DHCP server or from the attacker, basically. What happens sometimes that when we take, let's say, a small setup, we have a router and we have a switch, and then we have some end devices which are connected together like this. Yeah. So there is a possibility that there can be a indirectly connected router who is working as my DHCP server, right? This is, let's say, working as my DHCP server, and the router 0 is configured with the IP helper command to provide IP to end devices. Okay. But then an attacker gets into picture. This attacker connects itself directly with the switch. Now we know that there are four messages which are exchanged by DHCP. And the very first of them is discover message, which is sent out as a broadcast. So when this message will be broadcast, can I say it will also be received by this attacker or rogue DHCP? Yes or no? And after receiving this message, what do you think? Who will be able to reply back first? The legitimate DHCP server or this attacker server? The attacker server, as that is the one closerly connected to me, right? The legitimate has a hop in between the path, so it might take a little time, and this attacker server might reply back first, configuring the wrong gateway IP on PC 13 and PC 14. As a result to which all of the traffic generated by PC 13 and 14 will be routed towards this rogue DHCP server rather than the actual gateway. To protect ourselves from such attacks, we had something called as DHCP snooping. So let's learn how this works. First of all, I will configure my router with IP address and DHCP configurations. Enable config T hostname R1 FA0/0 IP address 192.168.1.1/24. No shutdown exit. Then I'll create a DHCP pool A for my network 192.168.1.0/24 with a gateway IP as 1.1. Exit. Then I will also go on my rogue DHCP server and provide the IP configs and DHCP configs. FA0/0 IP address 192.168.1.100.255.255.255.0. No shutdown, exit. And before configuring DHCP pool, let me first assign IP to PC 13 and 14 so that they can receive IP from the legitimate server only. Yeah, we got the IP from 1.1. Now this attacker gets into the picture with having a DHCP pool for the same network. 192.168.1.0/24 and with a wrong gateway as 1.100, which is basically this attacker's IP. Now, if I go to PC13 and I try using DHCP again, let's say, so there is a possibility that I might also receive IP from this ROG DHCP server. And if in case, let's say this router is down, let's say if I shut down the interface FA00 and go to the PC and try DHCP again, let's say. So we can see we are getting it from 1.100, which is the attacker. So at any time, let's say my original DHCP server is not able to respond quickly or is not available, this ROG DHCP server will configure these end devices with a wrong gateway IP, as a result to which all of my traffic will be routed towards this attacker. So how do we protect ourselves from such an attacks? We use DHCP snooping. Before configuring DHCP snooping, let me bring it up again and put the IP again on my PC13. Okay, I'll still, okay, this interface isn't up. Now I'll go to PC13, try DHCP again. Yeah, I got it from the legit server, which is 1.1, right? Now I want to make sure that even if the legit server is not available or not able to reply back on time, still my PC13 and 14 should never accept DHCP packets from this ROG DHCP server. For which I will go to my switch CLI and I will enable DHCP snooping here. The very first thing that we need to do is we need to enable DHCP snooping. So I'll say enable config T IP DHCP snooping. Enter. Then I will enable it for VLAN number 1, IP DHCP snooping VLAN 1. Enter. Now, guys, there is an additional option 82 related information, which is added on discover messages, which we have to disable by typing a command, no IP DHCP snooping information option. We are supposed to remove this additional information which my switch adds onto the discover message to make sure that DHCP snooping works correctly. If you will not write this command, your DHCP snooping might not work fine. After that, I need to specify that which interface is connected to the legit server. So in my topology, which interface is connected to the actual DHCP server? Zero slash 3, right? So I will go to my interface 0/3 and I'll say IP DHCP snooping trust. That means I trust this interface for DHCP packets. The moment I configure FA03 as trusted interface, all of the other interface automatically will be considered as untrusted. Okay. As a result, even if this router is not available, still my ROG DHCP server will not be able to assign IP to these end devices. So it's time to test it. I'll go back to my router number 1 and I will shut down interface FA00. Now it's no longer available. I'll go to PC13 and we'll try DHCP again. And you can see, even if ROG DHCP server is configured with DHCP configs, still it's not able to provide me IP address and my DHCP got failed. Similarly on PC14 also, if I try, it's going to get failed. Why so? Because on my switch, I have told that DHCP packets are only supposed to be accepted on FA03. So if the packet is not being received on FA03, then that is not a trusted DHCP server. So we will not accept those messages. This is how DHCP snooping helps us in securing our DHCP deployment. Let me know what questions or doubts you have in this. Yes, Jake, it will work fine with the DHCP server that you are using as it monitors the packets. So doesn't matter what type of server you have. I've shared this lab guide. Please check this and try out the configuration and let me know once you are done. Sham, the configurations are there in the lab guide. I'll open it here also. Anuj, it will work in the same manner with IP helper address also. So if let's say you have a DHCP server which is remotely connected to you, still you will forward the DHCP reply on FA03 interface of switch, right? So you will trust that interface only, not any other interface. If you have more switches, do we need to configure it on all the switches? Yes. Why are we disabling DHCP information option? Like I said, this is some additional information added by the switch, which does not let my DHCP operate correctly. So we need to disable it and then only we can work with it. Hi, laid back. Sorry to hear about that. We have discussed quite a good number of topics so far, so it would be a little difficult for me to recap everything right now. You can do one thing, just ping me personally once after the session. I'll see if I can ask my team to help you with the recording. Don't worry, laid back. I'll ask my team if it would be possible for us to arrange the recording, then I'll ask my team to reach out to you. Don't worry. All right, I hope everyone must have completed this. Now it's time to learn about something new, which is access control list. Let's see how the access control list works and what are the different types of access control lists that we can implement in our network. I'll share my other screen. Just give me a minute. All right, now my other screen must be visible. Let's understand what is ACL and how it is used. ACL stands for Access Control List. As the name defines, access control list is used for managing the access of certain devices. For example, let's say you are working in a hospital. Okay. In your hospital, you have this router here, another router here. This router is connected to a switch and then connected to a server. Here I have another switch which is connected to multiple users. You realized that these users are able to access this server, and the server contains some confidential data. Maybe let's say some details about your patients. Now you don't want anyone from your hospital to access this data which is present on the server. So for stopping or restricting this communication between these devices and this server, you can implement access control list. Okay. Access control lists are of two types. One is the standard ACL. And the second is the extended ACL. Standard ACL is quite simple and filters, or you can say restrict communications only on the basis of source IP. Okay. Whereas extended ACL gives us more options. It gives us the option of restricting communication on the basis of source IP, destination IP, protocol, port number, and so on. So let's understand these one by one. First of all, we have got the clarity that ACLs are used to control the traffic flow between the devices. Second is understanding the standard ACL and extended ACL. Like I said, standard ACL can filter traffic on the basis of only source IP address. Whereas when I speak about extended ACL gives me the option of filtering traffic on the basis of source IP, destination IP, as well as protocol and port number. So for example, if in this situation, I don't want these sources to make any communication with server. So what I can do is I can implement a standard ACL here, which will not allow the packets generated by these PCs to go beyond this router. So here I have stopped them. I will discard them right here. I'll not allow them to enter inside the server's network. That's my standard ACL. So what I did, I blocked the traffic on the basis of source IP. But now let's say I don't want these devices to have telnet connection with the server. I am okay that if they ping, they can ping the server, no worries. But if they try to take the telnet access of the server, or let's say if they try to take the HTTP access of the server, the web access of the server, I don't want that to happen. So in such a situation, we will go for which one? We'll go for extended ACL as it allows me to filter traffic on the basis of protocol as well. So I can create a ACL and I can apply onto my router to tell it that I don't want these devices to send two types of traffic, telnet traffic and HTTP traffic. So when we want protocol based filtering, we can go for extended ACL. Are we clear so far? Awesome. Moving ahead, the question is, where do we configure them? Do we configure them on router? Do we configure them on switch? Where exactly do we configure them? So let's understand. Standard ACLs will be always configured nearest to the destination and extended ACL are configured nearest to the source. There is a reason behind it. Let me tell you about that also. Let's say you have router 1 connected to router 2, connected to router 3. I don't want this PC of mine to have communication with this particular network. Okay. So I will implement a standard ACL here because I simply don't want a particular source to have communication with this network. But the question is on which router? Do I configure it on R1, R2, or R3? If I apply it on R1, what will happen? I will define a rule here that if a packet is generated by this source, then I don't want that packet to be allowed. So that will definitely stop my communication with this network, but will also stop my communication with this network, which was not required, correct? But if I configure it nearest to the destination, like we have mentioned here on router 3, then I'll be able to send traffic from this PC to this network without any issues. But if I try to send it on this network, then R3 will stop me right here. It will not allow me to go beyond that device. Make sense? That's why we configure it nearest to the destination. Now on R3 also, we have two interfaces where we can apply this ACL. We have this interface and we have this interface. Assume that this is 0/1 and this is 0/2. What do you think? Which interface is nearest to the destination, 0/1 or 0/2? 0/2, right? So on my R3, I will apply my ACL on 0/2. Now, when we apply ACL, there are two directions, inbound, outbound. Inbound means the packet is coming towards you. And outbound means packet is going away from you. Understand it like this. If this PC generates some packet for this destination network, it will first go towards R1. right? So for this interface of R1, it will be inbound traffic, correct? Yes or no? Then R1 will forward it here on this interface. So for this interface, it will become outbound traffic, right? As it is going away from the interface, correct? Similarly, for R2, here it will be inbound, here it will be outbound. On 0/1, it will be inbound. On 0/2, it will be outbound. So on my 0/2, I will apply my ACL for the out direction so that the traffic generated by this PC cannot reach the destination network. Is that clear, everyone? Perfect. Now the last thing is about understanding implicit deny. So when we create ACL, guys, a ACL looks like this. For example, if I give you an example of standard ACL, a standard ACL will look like this. Access control list 10. Okay. So 10 is the number which we are using for standard ACL. There is a defined range, which basically is used by the standard ACLs, and similarly a defined range for the extended ACL. I'll show you in the CLI. From 1 to 99, it is standard, and from 100 to 199, it is extended. So I created one standard ACL. Now I want to reject the packets generated from this source. So I need to know, first of all, the source IP address. Let's say the IP of this PC is 192.168.1.10. Then there is another PC whose IP is 192.168.1.20. Okay. So I created my ACL and I said I want to deny traffic from 192.168.1.10. And I applied it on my 0/2's out direction. Okay, so now if any packet will be generated and will try to go out of 0/2, my 0/2 will deny that packet, will discard that packet. But what if this PC generates a packet? When this PC will also try to make a communication, my 0/2 is going to deny that even. Why so? Because I never said that I want to permit 1.20. So along with telling the ACL that what you want to deny, it is also important to tell the ACL what you want to permit. Otherwise, there is an invisible rule in the ACL at the end of the ACL, which is deny all. So if you will not specify that what you want to permit, it will deny everyone. That's why before closing my ACL, we will add a rule saying permit all or permit any, which means after denying 192.168.1.10, I want to permit others. Clear? So that it can nullify the impact of implicit deny rule. And this will never be seen in the CLI. Like you will not see it in the output, but it is an invisible rule that stays there in the ACL to deny every traffic which is generated by a PC who is not permitted. Are we clear so far? All right. So now we will look at the implementation of standard ACL, where I will try to block the traffic from a particular device. Let me share my other screen. Okay, so now it's time to configure standard ACL on a given network. So I'll create a small network first of all. There is router 1, there is router 2, two switches, one here, then two devices for the first LAN, two devices for the second LAN. I'll connect them all like this. This will be my network 192.168.1.0/24. This will be 192.168.2.0/24. Between the routers, I will use 12.10.1.0/24. So let's go to the first router and begin the configurations. I'll say no, enable config T, host name R1, interface FA00, IP address 1.1/24. No shutdown, exit. FA01, IP address 12.10.1.1/24. No shutdown, exit. Then I'll create a DHCP pool, DHCP pool A for my network 1.0 with a gateway IP as 1.1. I will go and assign IP address to my PC. Then it's time to configure my router number 2 as well. So I'll say no, enable config T, host name R2, interface FA00, IP address 12.10.1.2/24. No shutdown, exit. Interface FA0/1, IP address 192.168.2.1/24. No shutdown, exit. Then I will configure DHCP pools on these devices. IP DHCP pool A for the network 192.168.2.0 with a gateway of 2.1. I'll go to PC 17, desktop IP DHCP. Yeah, the interface is not up yet. Now I'll try again. Now to make this network communicate with this one, I will put static routes. On my router number 1, I'll add a static route for 192.168.2.0/24 with a next hop IP as 12.10.1.2. Similarly, on my router 2 also, I'll put a static route for 192.168.1.0 with the next hop as 12.10.1.1. Now, if I go to PC 15 and try to ping 192.168.2.2, you can see we are getting the replies. If I ping 2.3, which is my other PC, from there also I am getting the replies, right? Now I will implement an ACL which can block the communication from PC 15 to the destination network 192.168.2.0, for which I will implement an standard ACL on my router 2, as that is nearest to destination. I will say config T, Access list question mark. You see, this is the range for standard. This is the range for extended. So I'll create access list 10 question mark. You have to tell what you want to deny, what you want to permit. So I want to deny question mark. What do you want to deny? Do you want to deny a network? Do you want to deny any? Any means all. Or do you want to deny a single host address? We want to deny a single host address, right? So I'll say host question mark. I have to put the IP of my host. The host IP is 192.168.1.2. That's how simple it is. Enter. After that, if I go to my PC15 and I make communication with 2.3, I get the replies. Why are we getting the replies? Because ACL is created, but we have not applied it yet, right? So that's why we are still getting the replies. Where do I apply it, on FA00 or FA01? Also tell me in which direction. Perfect. FA01. So I'll go to FA01 and I'll say IP access group 10. There are two directions, in and out, and we will do it for out, right? Exit. After that, again, I'll go to PC15 command prompt and we'll try to ping 2.2, and you can see it is saying destination host unreachable. Similarly, if I ping 2.3, I am not getting replies because I have restricted the communication. But because of implicit deny, PC16 also will not be able to communicate. If I say ping 2.2, it tells us that destination host is unreachable. So how do we fix that? We can fix that by adding another rule in my ACL. Currently, if I show you my ACL, this is how it is defined. Standard ACL 10, and then a rule is there to deny 192.168.1.2. And remember, I told you there is an implicit deny rule, which is an invisible rule, which will deny everyone. So to fix that, we will add a new rule into my ACL, access list 10, and we'll say permit any. After that, if I check my ACL again, now I have added a new rule, permit any. That means my device will check the packet from this particular sequence. First of all, it will check if the packet is coming from the source 192.168.1.2. If it matches the sequence, it will perform the deny action. Otherwise, it will move on to the next sequence where I am telling that I want to permit any. That means I want to allow all. So I will allow that packet and will permit that packet. So after adding this permit any rule, I will go to PC16 again and will try to ping again. And you can see this time I am getting replies on PC16 because we have allowed everyone else except PC15. This is how the simple ACL configuration is done. This is an example of standard ACL. Let me know if there is a question or doubt in this. So I'm repeating the configurations and the explanation again. The very first thing that we tried is to implement, first of all, routing between the devices using static routes. After that, I was able to make this network communicate with the destination network. Now using an ACL, I want to deny the traffic generated by PC15 for the destination 17 and 18. So what I did, I created an ACL on my router 2. I said, I want to create a standard ACL access list 10, and I want to deny the host 192.168.1.2, which is my PC15, right? Then to allow the PC16 or any other PC other than 192.168.1.2, we need to add the rule permit any so that the other IP addresses can be allowed. After creating this ACL, we had to apply it on the interface, which we have done on FA0/1. Okay, I'll scroll up. So on my FA01, I said, I want to apply the access group 10. This is how you apply it. Access group 10 is the ACL number that we created. For which direction? For out direction. Why is it out direction? Because assume that this is a packet. So this packet will move from PC15 to router 3. On FA00, it will be coming towards FA00. So that's inbound packet. From there, it will go out of FA01. Now it's going away from the interface. So that's outbound. On FA00, it is coming towards the interface. So that is again inbound. And on FA01, it's going out. So that's outbound. So we applied ACL on FA01 of this router 2 for which direction? For the out direction. Clear, guys? The commands and the lab guide is already pasted in the group. You guys can open it and try this lab now to test the configuration by yourself. Are we all done with the configurations? Any questions or doubts? Awesome, perfect. That would be all for today. In the session tomorrow, we'll speak about extended ACL and we'll understand how protocols can be denied using ACL implementation. After that, we will learn about network address translation. So let's see how that goes. Thank you so much. I hope you enjoyed the class. I'll see you tomorrow. Take care. Enjoy your day.